If you're searching for ways to bring more depth and dimension into your mixes, you've come to the right place. In this video, we're going to take a look at a few simple techniques that can be used to make your mixes more immersive and spacious. In addition to improving your mixing skills, learning how these techniques work will teach you a lot about acoustics and how humans perceive sounds. So go ahead and grab a notebook and settle in. First, I wanted to let you know that this video was inspired by a video series that was introduced to me in college called The Art of Mixing with David Gibson. The video seemed a little bit outdated even back then, but the tips and techniques in that series are still relevant today. Anyway, the first chapter of that video series introduces this idea that a mix is like a painter's canvas. The concept is called imaging because you're creating an image for the listener. Using the techniques I'll show you in this video, a mixing engineer can manipulate the positioning of each instrument on that canvas and ultimately create a three-dimensional experience. First, let's talk about width in a mix. When it comes to positioning the components of your mix in a stereo setup with two speakers, the two speakers usually mark the boundaries of your canvas from left to right. Of course, these concepts also apply to mixing in surround formats like 5.1 or Dolby Atmos, but for the sake of simplicity, let's stick to stereo for right now. The primary tool used for positioning an instrument from left to right is panning. A pan knob controls how a signal will be distributed between the left speaker and the right speaker. If I set the pan knob all the way to the right, my voice only comes out of your right speaker. And if I set the pan knob all the way to the left, my voice only comes out of your left speaker. However, if I set the pan knob to the center, my voice will come out of both speakers evenly, which will create a phantom image as if my voice is originating between your speakers, which I find fascinating. In addition to panning, we can also use delay to create width in a mix. Think about it. A sound originating on my right side will reach my right ear first before reaching my left ear at a slight delay. That subtle difference in time of arrival between the right ear and left ear will signal to my brain that the sound originated on the right side. And we can play upon that phenomenon called the Haas effect by adding a slight delay to the signal in one speaker. Now, even though the signal is the same level in both speakers, the listener will localize that sound to the side that reaches their ear first. You also have some bit of control over the perceived height of an instrument, although it's more difficult to control. Humans are just better equipped to localize sounds from left to right than top to bottom because our ears are on the sides of our head. It's much easier to control the height of each source in a mixing format with height speakers like 5.1.2, for example. In a system with height speakers, the same concept that we saw in panning left to right is used, just from top to bottom instead. In stereo, you can sometimes place an instrument lower on the canvas by embellishing the low frequencies, or higher on the canvas by emphasizing the high frequencies. I think this is most likely due to the fact that low frequencies can travel through the floor, whereas high frequencies cannot. The third dimension of a mix is depth, the positioning of an instrument from front to back. This is where it gets really interesting because there are so many different ways that you can manipulate the depth of a mix. The simplest way to adjust the placement of an instrument from front to back is to increase or decrease the level of that instrument. And that makes sense because sounds typically become quieter the further away from the source you get. So if I increase the level of my voice using a fader, it seems to bring me closer to you, and turning down my voice seems to move me further away. You can also add depth using reverb, and more importantly, the relative level between the direct sound and the reverberant sound. In a real-world indoor situation, if I'm relatively close to you, the direct sound of my voice will be much louder than the indirect sound reflecting off of walls. But if I scoot back, now the indirect sound is about the same level as the direct sound coming from my voice. And we can sort of mimic that using reverb in a mix. If the dry signal of my voice is much louder than the reverb, it will add depth to the virtual space, but my voice will seem to be up front in the mix. As the reverb signal increases in relation to the dry signal, it seems to push me back in the mix. As a source moves further away, the sound also starts to lose some high mid and high frequency energy. A sound source very close to you might sound defined and articulate, while a source further away might start to sound dull in comparison. Using this to our advantage, we can roll off some of the higher frequencies to push an instrument back in the mix, or boost some of the higher frequencies to add presence to that instrument. Make sure to watch one of the videos that's on your screen right now if you want to learn how to train your ears to improve your mixes. I'll see you there.